Alright, in this example, we want to solve for x, and to graph the solution set of x. Now we have a inequality with two absolute values on both sides, and that might be tricky for some people, so you really want to be careful of this one. Okay, so because 2x is an absolute value, we know an absolute value on the number line. We know its distance from 0 can be either positive 1 or negative 1. The distance will still be 1, right? So it could be positive or negative, and then when you divide by negative, it'd be essentially this. You write it as this. As the value of negative x minus 3 is less than or equal to 2x less than or equal to x minus 3. Because if right here, essentially, this is 2x, since it's an absolute value, if the negative absolute value and a positive absolute value must be the same, because the absolute value of this is defined as the distance from a point. It's like saying the distance from Earth to Mars, from Earth to Mars, it's either way. From Earth to Mars or Mars to Earth, it's still going to be a fixed or changing, distance or constant. So you can think of it as that way when you look at it on the number line. So you take this and essentially you get x minus 3 is greater than or equal to negative 2x, and 2x is less than or equal to the absolute value of x minus 3. X minus 3, right? Because you just divided it. Just divided is totally by negative 1. So now this might get a little bit complicated because each of these have two cases. So from over here, from right here, there are 4 cases. Okay, now we're going to solve the first case, which involves absolute value of x minus 3 greater than or equal to negative 2x. Okay, so x minus 3 absolute value of this binomial greater than negative 2x, this could be written as this. It could be written as x minus 3 is greater than equal or less than or equal to 2x, or x minus 3 is greater than or equal to 2x, negative 2x. Because as you can see here, negative 2x, if that's your 0 point, the absolute value is a distance, and the distance must be equal on both sides of this value. So it'd be less than this, or it'd be greater than negative this. Recall on a number line, if in order to from negative 1, you must add a value to go to 0. Oftentimes people get confused because they think, oh, I should subtract because it's going back to a lower number, but no, because you're in the negative range, you must add. So that's why it must be greater than a negative, because over here it must be greater than you reach 0. Okay, so when we solve here, we get x is greater than or equal to negative 3, or x is greater than or equal to 1. Now, with this right here, this is essentially the same thing. You get x minus 3 is less than or equal to negative 2x, or x minus 3, sorry, this is minus, it's not negative, minus, greater than or equal to 2x. Okay, so now after you solve this, you move that to that side, and then you divide by 2, so you'd end up with x is greater than -3 or x is greater than 1. And when you solve this for x, isolate x, you also get this. So you get this term or this term, this whole term, and x less than 1, or x is less than or equal to a -3. And now you can find this once again, this right here. You can find this right here by solving for x in this binomial, in this right here. Okay, so when we graph this, when we graph the first part, x is greater than -3. X is greater than -3. How do we draw? Okay, this is your number line right here. This is -3, and this is 0. And this is +1. Since it's greater than or equal to, it'd be a closed circle, so it'd be right here, and that'd be greater. And you have or x is greater than or equal to 1, so you have a closed circle at 1, and that'd be greater than or equal to 1. And then if you graph this right here, you would get -3, also closed circle, going the other direction, and you'd have 1 also going the other direction. Now, the important thing to say here is that these 2 points are essentially the same points going in each other's direction. In order to satisfy both values, it must actually be something like this. It must actually be, it must actually not be greater than this point or less than that point, but rather between exactly -3, +1, in order for the AND statement to be true. So it'd be between -1. They're both closed circles, by the way. So your solution set would be x such that -3 was less than or equal to x less than or equal to 1. And that would be your answer. Sorry, this thing was lagging. So yeah, right here, x such that x is less than, or -3 is less than or equal to x, which is less than or equal to 1. So essentially, x is greater than or equal to -3 and less than 1. So that would be your solution set, and that would give you a full credit on the test.